Calculus AP first 6 weeks test. This is a review of that test. And there are 24 problems total. I'm going to go over each one of them. First problem, what is f prime of x if f of x equals 5x squared plus 2x minus 3? Well, for that, we can use the power rule, and this 2 times 5 is going to be 10. And then we have x, and we take 2 minus 1, so it's going to be x to the 1 power. So we have 10x, and then we have the derivative of 2x, which is going to be plus 2. And derivative of minus 3 is 0, so this would be our answer for problem number 1. Problem number 2, what is the average rate of change of the function f of x equals 2x squared over the interval 1 to 3? So we do that. I'm going to just label these things. We'll let a equal 1, b equal 3. So we'll say f of b is going to be f of 3 or 2 times 3 squared, which is 2 times 9, which is 18. And f of a is equal to f of 1, which is 2 times 1 squared, which equals 2. So our average rate of change equals f of b, which is 18, minus f of a over b minus a. So that's going to be 16 over 2, which equals 8. So that's problem number 2. Next one, problem 3, find the limit as x approaches 3 from the negative side, if it exists. If the limit is infinite, determine if positive infinity or negative infinity. Well, we should be able to see that if we plug in 3 to this, we're going to get 3 minus 3 in the denominator, or 0. And numerator, we're going to get 3 plus 3, or 6. And so we're going to have a limit, an infinite limit, but if the limit is infinite, determine if infinity or negative infinity. And for that, what we're going to do is take a number just less than 3, since we're coming from the minus side. We can take any number less than 3. And to do that, we can take maybe 2. That's going to be from the negative side. So from the left side, we're going to have 2 minus x minus 3. Is that on the right? And on the top, we're going to have 2 plus 3. So we're going to have 5 over negative 1, which equals negative 5. And so we would say limit, let's say it right, as x approaches 3 from the negative side of, we'll just write down x plus 3 over x minus 3. We can say approaches doesn't actually equal negative infinity. And we could tell if we can go from the right side, we would see a positive number approaching positive infinity from the right side. The left side is going to be negative infinity. Next, problem 4. What is the limit as x approaches 2 of x squared plus x minus 6 over x minus 2 if it exists? First of all, we're going to plug in 2 And if we plug in 2 to this, we get 2 squared plus 2 minus 6 over 2 minus 2. And for that, we're going to get 0 over 0. Most students know that 0 over 0 stands for more work. And so what we're going to have is the limit as x approaches 2. The next thing we're going to do is try factoring. We're going to have x minus 2 in the denominator, and we know, since we got 0 over 0, that one of the factors in the numerator is going to have to also be this binomial factor x minus 2. And what times x minus 2 is going to equal x squared plus x minus 6? Well, it's going to be x plus 3. And so we have cancellation. And so we have the limit as x approaches 2 of x plus 3. And when we plug in 2 this time, we get 5 for an answer. So 5 is our answer to problem number 4. Problem 5. The function g is continuous on the closed interval from 3 to 5. The function has values given in the table above. The equation g of x equals 5 must have at least 2 solutions in the interval from 3 to 5 if k equals. Let's just go ahead. I find that a sketch might help. If we have a little sketch of what's going on here. We have we have x for 3 to 5, so we'll say 3, and then 4, and then 5. And we know that where, see, the table is g of x is 1 over here, and 2. So, and we're also given the equation g of x equals 5. So up here, I'm just going to draw another horizontal line. I'm going to label this g of x equals 5. Okay, let's go ahead and examine what's happening here. So when x is 3, g of x is 1. When x is 5, g of x is 2. All right, so we get from 1, from f of x, g of x of from 1 to 2, and we must have at least 2 solutions. Well, we can plug in values of k and see which one will get us across this line twice. If we plug in 1, we get this down here, and that's not going to get us anywhere near or across this line. If we try answer choice B, we get 2. Still doesn't work. If we try answer choice 3, which is 4, we get it closer to 5, but not there. If we get 5, well, 5 gets us right onto the line, but may only give us one solution. Right? So if we go to 6, however, we know we have to cross this line of g of x equals 5 once on the way up and once on the way down, and it's tripped from g of x equals 1 to 2. So the correct answer is going to have to be 6. Next, problem 6. If f of x equals 2x squared plus x plus 1 over x, then f prime of -1 equals. Well, I'm going to do what we call a calculus-friendly rewrite. I'm going to rewrite this f of x as f of x equals 2x squared plus x plus, and 1 over x is x to the -1 power. And f prime of x is going to be equal to 4x plus 1, and then we're going to take the derivative of this x to the negative 1 power. So we're going to have plus negative 1 times x to the negative 2 power. And that's going to be equal to 4x plus 1 minus 1 over x squared. And if we plug in negative 1, we get 4 times negative 1 plus 1 minus 1 over negative 1 squared. And for that, we're going to get negative 4 plus 1 and minus 1. So for this, we're going to get negative 4, which is going to be our answer to this problem number 6. Okay, the next set, use this piecewise function for questions 7 through 10. So we have this piecewise function here. Problem 7. The limit as x approaches 1 from the right of f of x equals. Well, the right side equation is this one on the bottom. So we'll say limit as x approaches 1 from the right side of f of x equals, we're going to just plug in 1. We have negative 1/2 times 1 plus 1. So that's going to be 1/2, negative 1/2 plus 2/2. So we're going to get 1/2. So 1/2 is our correct answer to problem number 7. Next, that's going to be this one right here, number 7. Okay. Now the limit as x approaches 1 of f of x, we have to have, for this to occur, we have to limit as x approaches 1 from the left side of f of x has to equal the limit as x approaches 1 from the right side of f of x. Well, we've already figured out the limit from the right side, and that's 1/2. So I'll just bring 1/2 over to the right side limit. On the left side, we have this x squared minus 2. So we're going to substitute in 1 for x. So we're going to have 1 squared minus 2. That's going to be 1 minus 2. So we have negative 1 equals 1/2. Is that true? No, it is not. They are not equal. So we say, I'll just put ... Therefore, the limit as x approaches 1 of f of x does not exist. Now you got to be careful. It's not equals does not exist, because that's part of the sentence. So the does would replace the is. So does not exist. It does not equals does not exist. It does not exist. So that's problem number 8. So I'll just draw a little arrow here. And f of 1, well, that's going to be the left side. So we're going to say equals 1 squared minus 2 equals negative 1. And then finally, is f of x continuous at x equals 1? Justify your answer analytically with math notation. Okay, since limit as x approaches 1 of f of x does not exist, f of x is not continuous at x equals 1. Some argument to that effect. So this is the right kind of articulation that we need to see, not exactly in those words necessarily, but something that makes an argument, an airtight argument. Next, assume that the limit as x approaches b of f of x equals 7, and the limit as x approaches b of g of x equals -1. Find the value of the limit as x approaches b of f of x minus 3g of x. Well, that's going to be, we're going to have, our answer to that is going to be the limit minus 3, and the limit of g of x is -1. So that's going to be 7 plus 3 is equal to 10. So 10 is our correct answer for problem number 11. Problem number 12. Evaluate the limit as x approaches 1 of f of x minus f of 1 over x minus 1 when f of x equals 2x cubed plus 4x plus 1. So I've created a little room here. What we're going to do is first plug in this function and see, well, first we have to find what f of 1 is, don't we? Because that's when we have to subtract. So we'll say f of 1 is equal to 2 times 1 cubed plus 4 times 1 plus 1. So that's going to be 2 plus 4 plus 1. That's going to be 7. So this limit as x approaches 1, we have to say, we're going to rewrite this as the limit as x approaches 1 of f of x, and f of x is going to be 2x cubed plus 4x plus 1, and we're going to be minus f of 1, so that's be minus 7. In the denominator we put x minus 1. And so what that's going to be is the limit, just simplifying, of 2x cubed and then plus 4x plus, well, it's going to be minus 7. 1 minus 7, it's going to be minus 6. And all that over x minus 1. Now substituting in 1, we're going to get 2 times 1, because 1 cubed is 1, plus 4. So we have 2 plus 4 minus 6. That's going to be 0 in our numerator. In our denominator, we have 1 minus 1 is 0. So we have 0 over 0. So what we need to find is a factor of, and if we plug in 1, if we use the zero factor property, if we plug in 1 for this x minus 1, we get a 0. So we know that x minus 1 should be a factor of 2x cubed plus 4x minus 6. And we could tackle that in different ways. One way that we worked this in pre-calculus last year was called synthetic division. And so for that, in the top bracket, we're going to put 2 in the x cubed place. And then we have 0x squared. Then we have 4x. And we have minus 6. And we have x minus 1. Well, for x minus 1, we have to use 1 as the value of k, because it's going to be x minus k to find k's factor. So we're going to go ahead and use synthetic division. We bring down this 2 in the x squared's place. 1 times 2 is 2. 0 plus 2 is 2. And 1 times 2 is 4. Well, 1 times 2 is 2. kind of looking ahead sometimes. 1 times 2 is 2. Now 4 plus 2 is 6. 1 times 6 is negative, 1 times 6 is positive 6. And so in this remainder column, we have negative 6 plus 6 is 0. So what we have is 2x squared plus 2x plus 6. So that would be our, after we divide. So what we have here is the limit as x approaches 1 of, we have quantity x minus 1, and in the denominator we also have x minus 1, plus we have this 2x squared plus 2x plus 6. And x minus 1 over x minus 1 canceled, equal 1. And what we have is the limit as x approaches 1 of 2x squared plus 2x plus 6. And what that equals is 2 times 1 squared, which is 2, and 2 times 1, which is 2, and plus 6. So our answer for this one is 10. So 10 is also an answer to problem 12. Next problem. 13. Find the vertical asymptote, or asymptotes of f of x equals x minus 3 over 2x plus 1. We can set our denominator equal to 0, or set it not equal to 0, because the vertical asymptote is where the function cannot exist. So we're going to set 2x plus 1 not equal to 0. And if we subtract 1 from both sides, we get 2x cannot equal negative 1. When we divide by 2, we have x cannot equal negative 1/2. So therefore, we say for our vertical asymptote, we say our equation for vertical asymptote is x equals negative 1/2. And that's problem 13. In problem 14, we haven't gone over trig very much, but we have find the limit as pi, not pi, I get this, as theta approaches pi of 2 theta 3 theta over 4. Theta cosine 3 theta over 4. So we're just going to plug in for theta pi. So that's going to equal 2, and we're going to replace that theta with pi, and we're going to have cosine 3 pi over 4. Well, 2 theta, 2 pi, excuse me. So we're going to have 2 pi times, and what's the cosine of 3 pi over 4? Well, it's going to be, if we look at our unit circle, 3 pi over 4 is going to be over here on the left, equidistant between the 180 degrees or pi and pi over 2. So our cosine of that is going to be negative square root of 2 over 2. And so what we have is 2 over 2 cancel each other. So our answer for this one is going to be negative square root of 2 pi. So that's our answer for number 14. Now, number 15, we have find the limit as x approaches 0 of sine 7x over 2x. This one here is a special trig limits application. And so the answer for this one is going to be 7/2. So we get trigonometry more. We're going more problems like this. Okay, number 16. Find the limit as t approaches infinity of 3t minus 5t squared minus t cubed over 7t cubed plus 2t minus 1. This is a situation that I've euphemistically called Betsy, where bottom equals top use coefficients, because we have negative t cubed and 7t cubed in the denominator. Negative t cubed in the numerator and 7t cubed in the denominator. So our answer for this is going to be -1 over 7. That's it. That's all there is to it. -1/7. Next, we have the limit as t approaches infinity of t squared over 2 to the power of t. Well, what happens is that there's a hierarchy of different types of functions, that a log function is going to be less than a polynomial function, which is going to be less than an exponential function. And so in this case, we have in the numerator a polynomial function, in the denominator an exponential function. So what we're going to have is the bottom is going to increase faster than the top. So our answer to this one, number 17, is going to be 0. Let's go on to 18. Use a table below to determine the limit as x approaches 3 of f of x. Well, from the left side, as we approach 3, what value is being approached? Okay, we're coming to 30 from the left side, 30 from the right side. So, to me, our answer to this should be 30. Number 19, given f of x equals x cubed minus 3 minus 2x plus 5 over an interval 0 to 2, which of the following values is guaranteed by intermediate value theorem? For this, I'm going to use a and b like we did for that average value problem. So f of b equals f of 2 which equals 2 cubed minus 2 times 2 plus 5. For that we get 8 minus 4 plus 5, which is going to be equal to 9. Next, f of a is equal to f of 0, and that's going to equal 5. So we have this function, just drawing a sketch like we did for earlier problem. We have a function here where we have at between 0 and 2, x equals 0 and x equals 2. At x equals 0, we have an output of 5, and at x equals 2, we have an output of 9. And so just kind of marking those 2 points. To have the intermediate value theorem, we're going to have a k value somewhere between 5 and 9. Well, the only place that we see that answered is answer choice C. Next, problem 20. Determine the value of k that makes the function continuous. Show your work. So we know we would have to have, for the function to be continuous, we'd have to have the limit from the left equal limit from the right. So if we just write limit as x approaches 5 from the left side of f of x equals limit as x approaches 5 from the right side of f of x. And what we have there on the left side, we have 5 squared, x squared minus k. And on the right side, we have 4 times 5 plus 2k. And simplifying, we have on the left side 25 minus k. And on the right side, we have 20 plus 2k. And if we subtract 20 from both sides and add k to both sides, we get cancellation there. What do we have left? We have 5 on the left side is equal to 3k. So k is equal to 3/5. I saw some people come up with negative 3/5. I don't know how you got negative 3/5. Anyway, that's our answer to and work for problem 20. Problem 21. Determine if g of x is continuous. Justify your answer analytically with math. Well, we have the function x squared minus 49 over x plus 7 when x is not equal to negative 7, and 0 when x equals negative 7. And so we're really interested at x equals negative 7. That's going to be our crucial, critical number. And so the conditions for continuity are, first of all, okay, if g of negative 7 exists, and we know that that is equal to 0. Next, 2, the limit exists. And to do that, well, we try to find the limit at negative 7 again. What we're going to do is plug in, and the limit as x approaches negative 7 of x squared minus 49 over x plus 7. That's going to be the limit as x approaches negative 7 of factored form. We're going to have x minus 7, difference of squares, times quantity x plus 7. In the denominator, we have x plus 7, and x plus 7 over x plus 7 can cancel. So the limit as x approaches negative 7 of g of x is equal to this. We're going to have x, well, we're going to have x is negative 7 minus 7, which equals negative 14. So condition 2 is met. Now condition 3, we have g of negative 7, in this case, does not equal to the limit as x approaches negative 7 of g of x. And why do we know that? Because negative 14 is not equal to 0. So therefore, g of x is not continuous at x equals negative 7. Okay, next, 22. The graph of f of x shown above, the graph passes through the points 0, 2 and negative 2, 0. which the following statements statements are true. Well, for one, the limit as x approaches -1 does not exist. Let's check the validity of that statement. Well, the limit does exist, and the limit does equal to 1. And so we know that statement 1 is not a true statement. Well, f of -1 does not exist. If we look at -1, we have a hole right above -1. I don't see any point taking its place. So it looks like f of -1 does indeed not exist. So 2 is actually correct. So anything without 2 in it, okay, is a gone thing already. Okay, 3, f of -1 equals the limit as x approaches -1 of f of x. Well, f of -1 doesn't exist, so it cannot equal. So this situation, our only possibility is answer choice B, 2 only. Next, a lot of people had problems with this one. 23, determine the horizontal asymptotes of the following function. Well, the only thing we care about are the highest power in determining what's going on here. And if we take this 9x to the 4th inside a radical in the numerator and this 2x squared in the denominator, well, let's look at that. And what we're going to get for this is we're going to get the square root of 9, which is 3, and the square root of x to the 4th, which is x squared. And in the denominator, we're going to have 2x squared. Now, I realize that I'm casting aside all these other numbers because relative to the highest powers, they do not matter. So this is a classical Betsy situation, so our horizontal asymptote is going to be y equals 3 over 2. So that's our answer to problem 23. Problem 24, use the definition of the derivative to determine f prime of x when f of x equals x minus 3x squared. And the definition of derivative is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. And to do this, we're just going to fill in. I'm going to just work below to give more room on this. Oops. Okay, so we're going to say equals the limit as h approaches 0, and we're going to take this f of x plus h. Well, that's going to be x. F of x is going to be x, so I'm going to put x plus h in place of x. And we're going to have minus 3. We're going to have x plus h, 20x plus h squared. And we're going to subtract out f of x. And f of x is going to be x minus 3x squared over h. And all this is going to be equal to, we're going to expand out, and I'm not going to have a whole heck of a lot of room here, but we're going to have x plus h, writing this real small, and we have minus 3 times 20x plus h squared. So that's going to be minus 3x squared minus 6xh minus 3h squared, and now we have minus x, and we have minus 3x squared, so that's going to be plus 3x squared over h. And we have cancellations going on here. We're going to have x minus x and minus 3x squared plus 3x squared. So what we have left is limit as h approaches 0 of what's left, which is minus 6xh and I forgot the plus h. I'm just going to put plus h and minus 3h squared over h. And when we cancel everything, we're going to get the limit as h approaches 0 of, we're going to have, I won't even draw that horizontal line, negative 6x h over h is going to be negative 6x, and h over h is going to be plus 1, and then we're going to have minus 3h squared over h, so we're going to have minus 3h. And what that is going to be equal to is negative 6x plus 1. That should be our answer. And if we go ahead and work this out, if we use a standard power rule, if we take f prime of x here, use this formula, we're going to get x, the derivative of x is 1, and we're going to have minus 6x, which is the same thing as below here. So anyway, that should be all of our problems worked out. I'm going to go ahead and upload this video later tonight so my students can take a look at it, and the others who are interested. Good luck in your future tests and endeavors. Thanks for viewing.